Hello KG5, this is Mr. K, back for some of your chemistry test videos. I hope you have all had a brilliant challenge week. You've learned something new and you've pushed yourself beyond your normal limits. And now I hope you've pushed yourself through a grueling chemistry test and you've come out on top. If you haven't, I'm here to help so that you can learn from the test itself, given that it's not about your score really. What matters is learning from the test. So question 1, what two types of particles does part A contain? You should be able to recognize this as an atom, and we've already got electron labeled, so part A should be the only two particles left in the atom. And if you remember PEN, so proton, electron and neutron, hopefully you've brought a pen to your test and you can then work out the other two. So electron has already been labeled, leaving only proton and neutron. You should also know that part A is actually called the nucleus. Moving on to question 2, how many electrons are there in an atom of magnesium? So for this you need to look at the periodic table, and the smaller number, which represents the atomic number, is actually going to be the same as the number of electrons in this case. It's not always true. And so your final answer should be 12. And write the electronic arrangement, underline the word arrangement here, for the atom magnesium. So we're looking for how the electrons are arranged in their shells. That's essentially what that is saying. How are they arranged in their shells? And this is used with 2, 8, 2. Okay, so 2 electrons in the first shell, 8 in the second shell, and then 2 in the third shell. You should know that there's 2 in the third shell, given that it is in group 2. So its last shell has to have 2, and it is in period 3 because it's got 3 different shells. Okay. Question C, use the diagram and your answer to part B to answer the following question. In what group of the periodic table is magnesium? And obviously it is in group 2. Explain your answer. 2 electrons in outer shell. Moving on to question 2. Another electron arrangement question here, and this one's for calcium. So this should be 2, 8, 8, 2. It's just below magnesium in the periodic table. And then chlorine, which is going to be 2, 8, 7. So you should be able to work out that chlorine would actually be in group 7, given that 7 electrons are in its outer shell. Question B, if calcium is heated and put into a glass jar of chlorine, a violent reaction takes place and solid calcium chloride is formed. Okay, the reaction proceeds due to the transfer of electrons. Now, because it says transfer of electrons, you should know this is ionic bonding. Okay, as it also is between a metal and a non-metal. So 4 marks here. Make sure you're aware of how many marks this is. So your first mark is going to be that calcium, because it's the metal, loses 2 electrons. Okay, and it loses the 2 electrons of its outer shell. So it loses these 2 electrons and it's going to give these to 2 chlorines. Okay, calcium loses 2 electrons. And then the follow-up statement, each chlorine gains 1 electron. And I like to put the word each here just because it's telling the examiner that you know there isn't just 1 chlorine, but there's more than 1. And then you got a mark for saying electrons transferred from calcium to chlorine. Okay, so it's already given you that hint in the question. You just need to say from calcium to chlorine. So you need to give the direction of the transfer of electrons. And then finally, the reason why all this happens is to make stable ions with a full outer shell. Oops, missed off the word with there. Okay, and for that you didn't need the word ions there, but you did need the word or words to the effect of they become stable because they gain a full outer shell. You could have also used a diagram here as representation. So I'm just going to rub off some of this so that you can see. And we'll do a diagram just to show you. So if you had calcium, I'm only going to draw the outer shell to save time. So we've got an electron there, an electron there, 2 electrons in its outer shell. And then we're going to have, let's use a different color for chlorine. It's a green gas, so let's actually just use and this is going to have a shell with 7 electrons in it, and the same for this one. Okay, and so we're going to show this electron being transferred to the calcium, to the chlorine, sorry, from the calcium to the chlorine. Okay, and then you could draw a follow-up diagram if you wanted, showing calcium as a 2+ ion and chlorine as a negative ion. Okay. And when we draw the final electron on chlorine, you want to make sure that it is different. So this electron here looks different to the rest because it is actually come from calcium, if you remember. Okay, so a diagram would also do. Next question. Calcium chloride is a solid at room temperature and has a high melting point, so we want to underline those key attributes. Explain why calcium chloride has a high melting point. Okay, and if it's got a high melting point, it must have strong bonding. And we've already established that it's ionic. So ionic bonds are very strong. Therefore, lots of energy needed to break them. And that's it, 2 marks for those 2 statements. Okay, whenever it's asking about high melting points, always remember, doesn't matter whether it's talking about strong covalent bonds or ionic bonds, always add this statement, okay, because it's pretty much 90% of the time worth a mark. And you're letting the examiner know that you understand that ionic bonds are very strong. Okay, question 3. In water molecules, atoms are covalently bonded. Draw a dot and cross diagram of a water molecule. So here we have water. I'm actually just going to make the hydrogen blue to make it stand out. Okay. So there's a dot and cross diagram. So you'll notice oxygen has 6 of its own electrons in red, and hydrogen has 1 electron, which each donate an electron to the whole outer shell of oxygen, but they're sharing these electrons, so hydrogen is also gaining one electron from oxygen itself. And this is covalent bonding, so they do share electrons. Now this is worth 3 marks. So 1 mark was for showing 8 electrons around the oxygen. Mark 2 was to show that there's 2 electrons in each hydrogen, and then mark 3 is to show that the whole thing is correct. You could also do this using circles. So if you had oxygen with its shell, 2 more shells, and hydrogen, okay, and oxygen has 6 electrons, 1, 2, 3, 4, 5 it's sharing, and 6 it's going to share, and then hydrogen has 2 electrons which it's sharing. Either diagram is fine. And then, as I've already discussed while doing that diagram, covalent bonding is the sharing of electrons, and this is asking for you to describe a covalent bond. So it's the sharing of a pair of electrons, and there are 2 marks here. 1 is for the sharing, and mark 2 is for a pair of electrons. Okay, question C. Diamond has a giant molecular covalent structure. The melting point of diamond is much higher than the melting point of water. Explain why. And this is only worth 2 marks. So the key difference here, as it's already told you in the question, diamond is a giant molecular structure, and it doesn't tell you what water is, but water is a simple covalent structure. So 2 marks that you need to specify. Mark 1 is to say what diamond is and why it's got a high melting point. So diamond has strong covalent bonds which need to be broken. And mark 2, water just has weak intermolecular forces which need to be overcome. Okay, and so the key thing here, which I go into in another video, is although water has strong covalent bonds, it is not these strong covalent bonds that you are breaking, but weak intermolecular forces between molecules. Okay, between molecules, not within the molecule. Moving on to question 4, and I've already done the diagram for you. So describe with the aid of a diagram the metallic bonding present in metals. Okay, so what we're looking for were positive cations, and these need to be regularly arranged, so a nice pattern in straight lines and rows. And then we've got our negative electrons, which are sort of moving around. And if we want to be more exact, you want the correct number of electrons. So each electron is a negative charge. Here I have 1, 2, 3, 4, 5. So I've got 10 positives. So technically I should have 10 electrons. Okay. But you could have also, instead of the diagram, done this in written form. And so the bullet points that you were looking for were regular arranged pattern of ions. Bullet point 2, tightly packed. bullet point 3, there are free electrons. And bullet point 4, weirdly, is hold the structure together. Okay, and these free electrons are a sea of delocalized electrons. Now, interestingly, students often draw these positive ions like this, right next to each other, but that doesn't leave room for electrons. Now, the reason for this is most students see metals as being solid, and normally when you draw a solid diagram, you have to draw the particles like this. Okay, that's what you're taught and what you need to do in the exam. However, in this case, you are going to leave space so that you can draw the electrons in place. If you didn't, you wouldn't be able to fit them in. And it's important to remember that these are all just diagrams. Okay, you may be wondering why here you're drawing the particles as apart, or the ions as apart, whereas in a solid diagram you draw them touching, and it's just a representation of what is actually going on. They are simplified versions of a complicated thing, and so you need to remember that these are just diagrams. They're not exactly how it would look in real life. You're using them for the aid of explanation. Okay. Explain how the copper kettle can conduct conduct heat. So in this case, it is the free electrons which can move, and they move the heat from one place to another by colliding with other electrons. Okay. And it's important to remember that these free electrons, they're going to, let's put pass heat on. Use your knowledge of the structure of metals to explain why they are strong. So the answer that you're looking for is the forces holding the metallic lattice, so a crystal structure holding lattice together, are strong, and because the ions are tightly packed. And finally why they are malleable, and that's because you've got layers of ions in that nice regular arrangement which can slide over one another. Okay, and that's the end of the test. Obviously you can pause and rewind the video as you please.